Hello, everyone, and thank you for joining our live session today. My name is Larissa. I'm an event planner at Reactor, joining you from Brazil. Before we start, I have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. The session is being recorded and will be available to view on demand here on the Reactor YouTube channel within 48 hours. Keep an eye on the chat. We'll be dropping helpful links and checking for questions for our presenter to answer. I'll now turn it over to our speaker for today. Thank you and welcome, Pamela.
All right. Hello, everyone. Welcome to our Python Plus Agent series. This is a 6-part live stream series. We are now halfway through. Week 1 was all about building agents, and we're using the new Microsoft Agent Framework for this whole series. And now for week 2, it's going to be all about building workflows where you're piecing together agents with some non-agentic parts of your systems as well. And workflows is what, many of you probably are going to be using for actual production scenarios in order to make these flows that go through your system and do really useful things. So if you haven't registered yet for the series, you can still register. That way you'll get follow-up emails and you'll get notified, when the next video is streaming. All of these are recorded. So if you missed anything, you can go back, you can watch the videos, you can grab the slides, you can go through the code. Everything is available for you to review and keep learning from. And of course, you can also give this series yourself if you're so inspired for your, colleagues, friends, family, etc. So for our workflow week, we're going to start off with today's topic of building your first AI-driven workflows. And we'll be going through all the basics of workflows, the anatomy of a workflow, building basic sequential workflows, using agents inside workflows, visualizing workflows, adding conditional edges to workflows, using structured outputs to make those conditional edges more reliable, managing state in workflows, and finally, a little demo of a full stack app that has a workflow. So that is the plan for today, is to get a solid foundation in workflows, and we're going to build on that in the next 2 days, adding even more workflow features. So if you do want to follow along with the code, all of the code is available in this repo that we've been using throughout the session. So we'll share this URL in the chat. And this will bring you to the repo. And you can see here when you open the repo, there's a big green code button. So what you want to do is click on that code button. And let me show you. Let me actually delete my code space so I can show you what it looks like. Let me reload. Okay, so when you click on that code button, you're going to see there's a big button that says Create Code Space on Main. So you'll click on that button there. And what this does, it opens a new tab that is running VS Code in the browser. And that VS Code has the whole environment set up for this project. So it's got Python dependencies. It's got UV, which we're using for manage those dependencies. It's setting everything up for you. So basically, you wait a few minutes for that to set up. And, by the time we start running the code, it should be all set up for you. Now, once it does set up, I do recommend running git pull just to make sure you have the latest code, especially if any of you are, still have your code space from last week. We definitely have added a lot of new code in the last day to the repo. So if you do already have a code space, or if you already have the repo checked out locally, do run git pull to get all the latest workflow examples in your repo. So we are going to be building on what we learned last week about what an agent is. And I saw some questions chat like, do you need to know last week to understand this week? Not necessarily. You could try jumping in now. We'll have this one slide recap of what is an agent, right? What did we talk about last week? An AI agent uses an LLM to run tools in a loop to achieve a goal. right? So we can build these agents that have access to useful tools. And with those tools, they can help answer users' questions. They can do what users want to do. Many of you have probably used coding agents. Coding agents, we talk to them and say, hey, coding agent, I want help refactoring this file or writing a test. And the coding agent has access to tools like to write files, make new files, edit files, has access to maybe MCP servers, so it can go and grab documentation and look at documentation, right? Access to run tests. It has all this ability to run tools so that it can get to that goal of, achieving that coding goal. So you can build agents for all kinds of scenarios. You just have to equip them with the right tools so that they're able to do what they need to do to get the right answer or to take the right action. So that is an agent. And if you missed last week, you can go back and learn much more about agents. We'll be using agents today inside the workflows, but we're really going to be focused on how we can chain agents together along with other useful things in our workflows in order to create these full flows. So now let's talk about workflows. So an agentic workflow is a flow that involves an agent at some point, right? We've all done workflows for a long time, right? We've been building workflows in our software and applications for a long time. A workflow just, goes from one step to the other to the other to the other, right? The difference now is that we're building these agentic workflows or AI workflows, whatever you want to call them. And these agentic workflows are interesting because we can bring agents in, and those agents can make our workflows more powerful because agents can do quite a bit once they have access to a powerful LLM and useful tools, right? So we can bring an agent at a certain point, and that agent helps with decision making. It helps with content generation. It helps with answer synthesis. It helps with research. There's many ways that you can use an agent, right? At the very least, there's a lot of workflows where I used to use regular expressions, and now I'm bringing in an agent because regular expressions are hard. And also, an agent can deal with fuzzy decision making better, right? So that's where I find LLMs might be particularly helpful. Is if you had all these workflows before where there was kind of these decision points where you had to write all this logic and maybe regex and some keyword checks and whatnot. That's a point where you might want to bring in an LLM or an agent in order to handle that decision making about what to do next in the workflow, right? So you can start to imagine the workflows you have now, and if there are points in that workflow where it would make sense to bring in LLMs or agents. Now, you should keep in mind that not all calls in your systems should be agents, right? Or should be LLMs, right? Every time that we add a call to an LLM, we are increasing the non-determinism of our system and increasing the possibility of a failure or a safety risk, right? So we do want to be really thoughtful about where we're using LLMs and agents, and only add them in when they're really adding value to our workflows and maybe opening up workflows that we couldn't even do before, right? Like some of these workflows might be brand new ones that are replacing flows that humans had to do before. And now those flows can be largely automated, right? On Thursday, we're going to talk about bringing humans into the loop, because a lot of times you can automate like 90% of a workflow, but you do want to, a human in at one point just to, give the thumbs up, give a little editing, that sort of thing, right? So start thinking about where you might start making agentic workflows in your systems. Now, in Microsoft Agent Framework, which is the package we're using for this series, workflows have a certain anatomy to them and certain terminology. So we're going to learn that terminology first. So workflow is basically a graph, right? A graph has nodes and edges between them. So in Agent Framework, each node is called an executor, right? So each of these are executor nodes. And then we have edges between them. And these are just called edges, right? And a workflow takes input and it produces outputs. And the executors can either produce outputs and or they can send messages to the next executor. So basically here you can see I have like a sample executor, and this first one here sends a message where it receives some text and then it uppercases that text and sends it to the next executor. So that's an example of message sending. So a lot of times the executors that are like in the inside of the workflow are going to be using message sending. And then for the final executor, that's the one that's using yield output. And that's yielding output that then can be accessed outside the workflow. Now you can have a mix of these, and you can have ones that both send messages and yield outputs if you want those outputs to be available after the workflow ends. It's really, with the messages, it's about what you want to send between nodes in a workflow. And with the output, it's like, well, what do you want to be able to access once the workflow is done, right? So you may have some internal executors that both send messages and yield outputs, but you definitely want to have one at the end that yields an output, so you have something useful that comes out of your workflow. So how do we build a workflow? So here's the actual code, right? So from our agent framework package, we import the workflow builder. Then we set up executor classes. So here, what we've done is made a subclass of executor. So each of these is actually a subclass of executor. So here's an executor subclass, an executor subclass, an executor subclass. And then we say, okay, workflow builder, here's your start executor. So you have to tell it what node to start off on. And then you add edges. So you say, okay, from that start executor, you're going to go from there to this one. And then from this one, you're going to go to this one, right? So we say what the start is, and then we add edges from one to the next. And then we build the workflow. And once we build that workflow, then we can run that workflow with different inputs. And then after we run it, we can get the outputs from it. So this is your, most basic workflow. So here I have it running. So it's an examples, a workflow, RAG, ingest. And this workflow does not use any LLM at all yet, because I wanted to show the fact that, we can build workflows for anything. The workflows don't have to use LLMs or agents. So this very first one actually does not use any LLMs or agents. So this is a data ingestion workflow that takes a document, a PDF document, and extracts the text from it, then chunks it up, splits it up into pieces, and then generates embeddings for each of those pieces. So let me go ahead and run this. I'll do UV run examples workflow rag ingest.py. And let me show these executors, right? So here you can see, to make our executors, we just make a subclass of executors. So this is how we make a subclass in Python. We say, here's our new class. Here's the class name. We are subclassing executor. And then we add methods in that subclass, and we add the handler decorator. So this is really important. This shows agent framework that this is a method that is going to handle messages from other executors. So the key thing is you make a subclass, and then you add methods, and you put this handler decorator on the methods to say, hey, this executor node receives messages, right? So it receives a message, and that message has the path in it. And in this case, it takes that path and it uses a package called marketdown in order to turn it into string. And then the crucial thing here is that it sends a message to the next executor, which says, okay, here is what you need, which is the text version of this PDF. So then the next executor receives that text that's actually marked down in its handler method. And this one does some splitting into paragraphs. And then once it has these chunks, which is a list, it sends a message with those chunks. So you can see how each of the executors can send messages with different data types. And the next executor in the chain will expect that it's going to receive a message of that type. So you see here, this one expects to receive a list of strings. So it's, oh, okay, great. You gave me a list of strings. And now this one makes vector embeddings of each of the strings and outputs it. So this is how you build a sequential chain of executors. Each of the methods accepts an input of the kind of message they're getting sent. They send a message out, and the next executor expects that kind of argument and then sends the next message out. And then we can see the results. So we can see that we did the extraction, we did the chunks, and we got the embeddings. So here, this workflow worked. So you can use this workflow concept for all sorts of things. Now, something that's really cool is that in Agent Framework, there's this built-in WI. And earlier in this series, we saw how to use this with agents, but we can also use it with workflows, and it has a whole different visualization. So in order to use this WI visualization, we import the WI, and this is in a separate package that we have in our Python environment. And we serve the workflow from WI. So I can go like this and say, all right, open this up in WI, and that's going to serve it in the WI interface instead of actually directly running it, which is what I did the first time. So almost all of the examples for this series do have this optional WI support because it's really fun. So here we go. We have it open in WI here. So this is what it looks like for workflows. You'll see the executors, you'll see their chain. You can do different things, like you can change the layout. I usually prefer horizontal for myself. You can move stuff around if you want, just to help you visualize. Let's just auto arrange that. Okay. So now we can run it. So we'll go ahead and give it the input, which is example sample document.pdf. Okay, so this is just input to the workflow. So this is also an easy way to try your workflow out with different inputs, right? So instead of having to write those inputs in your code, you can start up your workflow and just keep trying it out with different inputs in this WI instead. So here you can see the first two nodes did go by really quickly. So we can see the extraction node, and we can see the text it extracted from the document. And then the chunk has a list of chunks. So you can see that's got a embedded list there. And then the embed is still running because that takes the most amount of time because it's actually going out to an embedding model. So we can see, as it's going through the execution, it's still running. We can also see events happening over here. These are more granular events. So as it's going through the workflow, there's quite a few events that get called, and those will show up here. And then if we did have open telemetry enabled, which we talked about on Friday, then you would also see open telemetry spans. I didn't actually enable it for this one, so we don't see them. But it's super easy to enable it, like we talked about on Friday, and then you could see it. All right, the embedding call is being a little slow. So it hasn't shown up there. And this is also a good way to see, what are we waiting on here? All right, and we're going to keep on using it WI for other workflows. So we'll keep seeing other ways of the different ways that workflows look in WI. Okay, so now that we've seen a workflow that wasn't using LLMs, but here we're talking about agentic workflows. So how do we bring agents into our workflows? So Agent Framework makes it very easy where if you want to have agents in the workflows, you can just directly add the agent. So if you have an agent, right, you declare it with agent, you say, okay, I have an agent. This is an agent. It's got a name. It's got instructions. Usually it's going to have tools as well. And if you just have that agent instance, you can directly pass that in as nodes in your workflow. And then Agent Framework will basically wrap them and turn them into executors. So they'll show up as agent executors in your workflow. But it takes care of doing that for you. So as long as you add the agent to your workflow, it'll just make it into a workflow executor for you, right? So in this really simple example, we have two agents. We set one of them as the start executor, and then we add an edge from the writer to the reviewer. So from one agent to another, and that's it. That's our very simple workflow. So going to, it did finally, there we go. It embedded. Good job. And then we see all the results. So some of your workflows might have slow parts. All right. So now let's go ahead and try out the agents example. So I'll go ahead and open workflow agents.py. And let's open that in DevUI as well. And this is a writer reviewer. writing all of our social media posts. I have to say they are pretty good at writing LinkedIn posts. All right, so we're opening this up. So you can see it's just 2 nodes, and these agent classes got turned into agent executor nodes. And so now we can go and run this workflow, and we can give it an input, and we're going to say, write a 2-sentence LinkedIn post, why your AI pilot looks good but fails in production. Okay, so now it's going through them. Let's open up our execution timeline here so we can see it running. And we can see the writer output. So the writer both has an output and sends a message. So here's what it came up with. And then here's the reviewer. It says nice, it's on point, it's clear, structure. It did give an optional Titan rewrite. There we go. So it did come up with a rewrite here. So here you can see, this is what happens when we chain 2 agents together. And this is a very common pattern, is the writer reviewer pattern. Especially if you use a different model for the writer versus the reviewer. In this case, I'm using the same model, but you might find that you really like some models for writing, but then really like other models for reviewing, or you just might give it a different system prompt that makes the reviewer be really critical, right? But generally what we find is that if you do add a review phase or a reflection phase, then, it often can lead to better results. So that's why you're going to see this writer, reviewer, editor, that sort of pattern come up quite a bit with these workflows, because it is such a common way of working with LLMs. All right, so there we go. We've got our basic workflow. And once again, all we had to do is define the agents, and make a workflow with a start agent and an edge from the agents to each other. So that's all we needed to do in this case. We didn't have to do custom executor classes, because the agent gets turned into an executor automatically. Okay, so in WI, we also showed, there's all these events happening, right? Now, when you are processing these workflows, you can also process these events. Like, you can process the workflow one event at a time. You can just handle events different ways. So we have this example here, workflow agent streaming, which shows how you can hook into these events. So this can be helpful when we want to have more granular output. Like if you're building a front end for a workflow, a lot of times it's going to be slow. And so you want to convey what's going on to the people using the workflows, right? Like DevUI is nice because it shows you all the stuff, but DevUI is for development. This is a tool for us to use as developers. If you are building a user-facing application, you're going to build your own UI on top of the workflows that shows like, hey, this is what's happening, right? So generally, you're going to want to hook into these events, and you're going to figure out which of these events you actually want to hook into. But as a general practice, when you are building user-facing applications, especially ones that use LLMs, which tend to, be high latency, to be slow, you want to convey the progress so that the user understands, what is going on. Is the workflow progressing? Is it stuck somewhere? Everything that's going on, right? So what you can do is when you run the workflow, here we're saying workflow.run, we give it our input, and then we say stream equals true. So this tells it it's going to stream the events and the output as it happens. So you can see for every time I get an event, I check to see what kind it is. And, I show particular outputs for different kinds of events. And this is also streaming the actual output from the LLMs. So I have special treatment for that, so that when it prints it out, it doesn't add a new line. It just prints it out one token at a time. So this one here is printing one token at a time. And the other ones are just, straight single events there. So let me go ahead and run that so we can see what it looks like. And I'll run this in the console so that we can actually see all these print statements here. Okay, so we can see event started. That's the started event. and we can see what the name of the workflow is. So we can output different things as we're going on. Okay, then we had a bunch of things happen. Executor invoked, executor completed, and we saw the output from that stream in. It was really fast, so it was hard to see. That was really fast too. Executor completed, executor invoked. This output streamed out as well, and then executor completed, right? And this isn't even all the events. There's actually more events than this. These are the ones that I thought were the most interesting to show, but you can hook into quite a few events and decide how you are going to use those events in your systems, right? Now, this is such a common common thing to do is to just make this linear workflow of agents. So there is actually a built-in workflow builder in Agent Framework for this. So it's called Sequential Builder, and you get it from the orchestrations package, and you just give it a list of the participants, right? So this just makes it just a little bit easier to do the thing we were already doing. So here, that's in workflow agent sequential. And we can see here, once again, we have the writer, we have the reviewer, and it's just slightly less code, right? We just say, okay, we're making a sequential pipeline here. These are the participants, and done, right? So let's go ahead and run that one. And it's going to look pretty similar from the command line. So here it's once again writing a LinkedIn post, and it's going to send it to the writer first and then the reviewer. And I think I saw a comment like, oh, why do you, in this case, why do you chain an agent to a reviewer together? Why not just, why not just have the writer do its own reviewing? Because you could actually equip the writer with tools, and that would be another approach. And yeah, that could be a totally valid approach. So there's many ways you can work with LLMs. I think I would say the advantage of having them being two separate agents is that you might use a different model entirely for the reviewer agent, and that you can really only do when you have them as two separate agents. So that to me is a big advantage, being able to have the two separate models. And the other advantage is different tools, right? So you might give the reviewer access to tools that the writer doesn't have. That may not be as common, but generally that's the reasons why you might separate, is different model, different tools. Or if you had a vastly different personality and you felt like you wouldn't be able to direct, the writer to really review itself with the same critical eye, and then you could have a really different personality in the reviewer, which isn't kind of poisoned by the original prompt of the writer. So there's various reasons why you might want to separate out your steps into different agents. So here we can see we got the user, we got the writer, the reviewer. So that worked. And that looks really similar to what we did before. What I do want to show you is what it looks like in Dev UI, because what you'll notice is that it has a slightly different set of nodes than the last one. So here, when we use Sequential Builder, what you see is that there's two additional nodes. We see an input node and an output node. And the reason we have these two additional nodes is because they are making sure that everything, all of the messages in this pipeline have to be shaped like a conversation. Because remember that first time we were talking about how let's see, workflow, this one, right? When we were doing the executors, they all had different arguments that they accepted, right? And so they would only work with arguments of a certain type. In this sequential pipeline, all of the messages have to be shaped like a conversation. They have to be a list of messages. And luckily with agents always send messages as lists of messages. That's just the way they always talk. And so this first node here just turns the input into a conversation shape, a list of messages. So it'd just be a list of a single message. And then this last node here turns any output into into the expected output. So it's just a little bit of extra executors on top just to make sure everything is shaped like a conversation. So you can only use sequential builders with agents or with custom executors that process conversations. So that means that the input they expect is a list of messages, and that is the message they send along as well. So that is restricted, but it's also this is going to be a pretty common flow for people to do, or at least to start off with. So they do make it easy to do it in Agent Framework, so that you can just run this one line of code, and boom, you have a sequential pipeline of agents. All right. So now we've seen these linear workflows, sequential workflows. Now let's talk about branching workflows. And that's where things get more interesting, because you can decide to go one way or another way based off the output of a particular step. So we're going to start with this basic example of a workflow with a conditional branch. And the way we do this is that we can add edges with associated conditions. And those conditions are actually functions that return true or false. So let's take a look at this conditional workflow here. So this one, we have a writer, a reviewer, and an editor. So our workflow starts off with the writer, and then we have an edge from the writer to reviewer. So it's always going to get reviewed. Now the reviewer can either go to the publisher if it's approved. So the reviewer is going to output and say approved or not. And if it is approved, it'll go to the publisher. If it is not approved, it's going to the editor. So the interesting thing is, how do we decide whether it's approved or needs revision? So these are actually functions. So we can go and look at these functions. And here they are up here. So is approved takes it a message. So these condition functions always get sent a message. And this looks at the agent's response in the message and just checks to see whether it starts with approved. So if you look at the reviewer, you can see the reviewer, it says, important, your response must begin with exactly one of these two tokens, approved or revision needed. And that's, I would say that's more than one token, but anyway, it needs to start with one of these two, phrases. So the is approved checks to see whether it starts with approved, and needs revision checks to see if it starts with revision needed. So that's it. So based off that, these functions are going to return true or false. So if is approved returns true, it goes to publisher. And if needs revision returns true, it goes to editor. So now let's go ahead and try this out. We'll try it in I'll try it in DevUI first. Okay, so we're gonna open up this conditional workflow here. All right, so we see the writer, reviewer, and then we see the edges, right? The reviewer is either gonna go to the editor or the publisher. So let's go ahead and give it some input here. All right, write a LinkedIn post predicting 5 jobs AI will replace. Okay, we're generating rage bait here, as we do. So we can see that the writer is working on it currently. Okay, so the writer wrote its initial LinkedIn post. Then we've got the reviewer running. And let's see if the reviewer is going to approve or say it needs revision. And this step really depends on your model. So the model I'm running locally is GPT-5, and it is a very critical model. So it almost always says that a revision is needed. But if you're running these in GitHub code spaces, those are with GPT-4.1 mini, and it's not as critical. So it might just go and approve it all. So which branch it takes is so dependent, right? It depends. I mean, it depends on the model, depends on like what it, the randomness and what came up with that time, right? There's so much non-determinism here. In this case, the reviewer did say revision needed. So then it went to the editor, and the editor came up with its result here. And in this case, this was the final executor. We could have made this graph, this workflow a bit fancier and had the editor go back to the reviewer, or the editor go to the publisher, or anything like that. But in this case, we end with the edited post here. And this is our new post. So here we go. So, in this case, it went down this edge here. So that worked. However, there is something that I really don't like about it. And I don't know if many of you, notice that. I do see some comments, right? Oh, there's a comment like, is there a fallback if it doesn't return approved or needs revision, right? So that sort of question is a great question, right? Like this here feels a little funny, right? Like, first of all, we're just checking, to just string. We're just doing the string check, right? So that's an issue, is that we're doing, just a string check. And the other issue is that we don't have a fallback, right? So these are all issues. So we're going to see ways that we can improve our conditional workflows to be more robust, more reliable, have more kind of fallback stuff. So we have different strategies that we're going to see here to make more robust workflows. So the first issue is that text output is fragile, right? So I had the system prompt that says, oh, your response has to begin with approved or revision needed, right? And then, these condition functions that were based off that, but so much can go wrong there, right? Like, first, it might decide to stick like some other text in front of it, and then we won't match it. It might decide to return in Spanish. Like if the input was Spanish, sometimes it might decide to return its output in Spanish too. I've definitely had that happen with GitHub Copilot. Every so often it'll go into Spanish or even Mandarin or something, right? It could start off with approved, but then have a but afterwards, right? Where it's like, well, approved, but right. And it might even end up saying both those things, right? And we just don't even know what it wants here. So we want to have a very clear signal that is always the same, and it's always very obviously approved or not. So what I recommend using is structured outputs. I think we talked about structured outputs last week. It's certainly something we talked a lot about in our Python AI initial series. But basically, when an LLM supports structured outputs, you can tell it what JSON schema it should conform to, and it will force the output to conform to that schema. So this is a very, very useful tool, particularly in workflows where along the way you want to have these structured outputs from LLMs so that you can really, really make clear decisions off the output. I really only want to have free text output, I don't often want free text output. Maybe I want to add the end of my workflows, but that is the default, is to get this free text output. And that's fine if what you're doing is answering a question, generating content. But if you are doing decision-making, classification, extraction, any of that, then you really want to be using structured outputs instead. So how can we do that? So what we're going to do is with our agent, right? Because here we were using an agent. With our agent, we're going to say that it's going to use response format, and we're going to set that equal to a pedantic base model. So let me just open this up so we can see the full code. This is workflow conditional structured. Okay. So we bring in base model from pedantic. That's a way of defining well-typed objects in Python. And we make this review decision, and we say, okay, this review decision class has a decision field, which is one of these literal strings, either approved or revision needed. It has free text feedback, which is a string, and it has the actual post text that it can pass along, right? So this is basically here just so it can pass it along. The LLM, what it's doing is making a decision, and if it's saying revision needed, it's going to give feedback. And if it's approved, it's going to pass along that post text. So there we go. So we have that review decision. And then when we create our agent, we say, hey, agent, you are going to use this as your response format. So we pass it in as a default option to the agent so that it knows that when it makes its calls, it's going to tell the LLM like, hey, you need to conform your output to this model here. And so then when we have the edges, so now if we look at the edges, we can see the edges first call this helper function here that takes in the message from the agent and it gets back the value from the agent. So dot value, when you're using structured outputs, dot value will give you back the actual parsed class, right? So this should actually be a review decision instance, right? So when you're using structured outputs, agent response dot value should contain the structured output object. So then in our actual condition functions, we parse out that structured output, and then we can actually be really specific and say result dot decision. So here we're actually saying, hey, this result is a review decision. I'm looking at the decision of it, and I'm checking to see if it is equal to this exact string literal. So we're still doing string checking, but this is much more structured because we're actually looking to see, oh, there's this decision field inside the output, and that decision field is either set to this exact string or this exact string. Because by saying this literal here, this is going to get sent to the LM and saying, hey, LM, you have to do it in one of these two, with one of these two literals. Now, your LLM has to support structured outputs for this to work. Most of the modern LMs do support structured outputs, but if you're doing like local models or some like alternative open source models or something, they may not support structured outputs, or they just may not have very good support for structured outputs. So it is really important that if you are using structured outputs in your, for your agents, parts of your workflow, that you are actually using a model that has very good support for it. And what does it mean for a model support structured outputs? So it is actually for the modern LLMs, it is part of their training process. So when models get trained, they first get trained on like the entirety of the internet, and then they get trained to be chat tuned so they can respond to messages. And then as an additional phase, they get trained to know how to output structured outputs. So that is how you get the best support for structured outputs. Now, it is sometimes possible to use LLMs for structured outputs even without the training, if there's a layer on top that tries to force it. So Olama, if you are using Olama like for local models, it does actually have a way of forcing all the models to output structured outputs, but it's not going to be as reliable. So the best support for structured outputs is from LLMs that had it as part of their training process. So OpenAI, first came out with it, a year, 2 years ago, time, who knows? But since then, most LLMs have added structured outputs to their training process because it is just so helpful. And you could still have it is still possible that the result may not agree. So you still may want to have a fallback, but I've found that generally they're quite good at complying. All right, so let's go ahead and try this one out. I'm going to do this locally. So the workflow is the same workflow we've seen before. Oh, I did add in another edge here. So writer, reviewer to publisher, reviewer to editor. I stuck in another edge here for fun, editor, reviewer. I think I just did that in my local copy and just before, just for fun. So here we're running the workflow. And I'm just doing .run without stream. So that means it is going to take some time to run here because it's going to go through all of the outputs before it shows everything. So this one, okay, we're doing the LinkedIn post again. And yeah, so that's running there. Let me also, I guess I'll also run it in DevUI at the same time, just because it's, when you're not doing streaming, it can be a little slow to wait for the full output, right? Conditional, structured, and DevUI. Okay. All right, so now So here you can see what the workflow looks like. And I'll just tell it, write a 2-sentence LinkedIn post about why AI is so hot right now. Okay. All right, there we go. So that's going to run there. And then let's check on here. All right, so now this one is done. So we can look and see everything that came out of it. So we had the prompt. And then the first output came from the writer. So this is from the writer. And then this is what I want to show you is the next output came from the reviewer. And this time the output is JSON, right? So we can see the output says, we've got an actual field that says decision revision needed. And then we have the other fields like the actual feedback here, right? So we can distinguish between them. And then we have the actual post text. But the really key thing here is that that decision, the thing that we're using for the conditional function, is in its own field. And we can just pull out the decision and know, hey, that's the decision and that's it, right? So since this one was revision needed, then it went to the editor. Now it went back, since I did add that branch to go from editor to reviewer, this time the decision is approved. So we can see decision approved. And we can see back it says, oh, it's, polished and published ready, no change needed. And then there's the post text. And then finally, it goes from the reviewer to the publisher and it is publishing it, right? And we can see it's also doing this in the dev UI, decision approved. And so this one should end up going to the publisher. So there we go. It's much better to use structured outputs for decision-making nodes. So that is what I would highly recommend. All right, now there was also a question like, oh, what about fallbacks, right? And also, like what if you just have like lots and lots of, places you could go based off the many different values of, a particular, output from the structured outputs, right? So now we're going to look at doing category-based routing with structured outputs, right? So a very common thing would be to use an agent to do some classification and say, all right, there's all these different buckets, all these different categories that, where we could potentially categorize this input as. Let's categorize it. And then based off the categories, we're going to send the message to, a different handler, right? So this is, a really common pattern that you can imagine. So in this case, this is for like a customer support scenario. The customer says, oh, how do I reset my password? That goes to the classifier agent. The classifier agent uses structured output to say, oh, this is a question, not a complaint or feedback. Says this is a question. And so then we have a node that's specifically just for figuring out extracting that category from the structured output. And then that sends it to the right executor based off the category. So there's a special way of doing this in Agent Framework. It's called a switch case edge group. So if you remember switch statements, we don't actually have switch statements in Python, but there's many languages that do have switch statements, which is a way of switching between many possible values for a particular variable. So you can switch between these values, and you can also have a default fallback for the switch case. So we basically have switch statement, but for our workflow. So what we do is we add a switch case edge group, and it has a node that's in charge of just getting out the results. And then, based off of that, it's going to go to different targets. And then you can have a default target here. So for some reason, none of those conditions were true, it's going to go to that default. So that is in workflow _ switch case. And here we've got it. I'm gonna start running it now, just so that we give it a little bit of time. Switch case. Okay. So here, the start executor is the classifier. The classifier goes to the category extraction, and then the switch case edge group goes from that to different targets or the default target based off of how things are categorized. So if we look at the extract category, that extracts out the result from the structured outputs, and then that gets sent to is question. And so that can just directly check message.category and say, oh, okay, message.category is question. So this is just it's really similar to what we did before. It just makes it just even a bit easier to do, routing to multiple places and to handle this common situation where, you want to do maybe a little bit of massage between the output and what your condition functions are going to be using. All right, so we can see that worked. So it says, how do I reset my password? This is classified as a question, and then it routes it to the correct QA team. I see the question about whether switch case is overkill in this point. Yeah, you may not need switch case, right? But you might find it makes your code cleaner. I mean, in this case, like you can try different things. You can try adding edges with conditions, and if it works, great. You could also try using the switch case instead, and you might decide you prefer that. It is nice that it has this default kind of built in here, and it just kind of reads nicely where you can see what the default is. So I think that could be an advantage of using the switch case. All right. Okay, we have 10 minutes left. So we're going to talk about state management in your workflows. So why do we even need workflow state? So in like the examples I just showed, the writer, reviewer, publisher, the end goal was to publish that text, right? The actual post text, the LinkedIn post text. And so the writer output that and then had to send it to the reviewer, who sent to the editor, sent to the publisher. All of those nodes had to carry along that post text just so it could get to the final output, right? So what we see is that when we don't have state, our executors might be passing along information that they themselves didn't produce, right? They're just kind of passing it along from a previous node. And that's we don't want to ideally the executors are only outputting what came from them. So what we can do instead is that we can add state to our workflow and say, oh, okay, the writer wrote the text, we're going to store that text in the state, we're only going to update it if it needs updating, right? So the only person who would be updating it would be like when we add the editor inside this workflow, like so the editor could update that post text, but reviewer should only be reading it, and publisher should only be reading and outputting, right? So it makes a lot more sense to actually store it explicitly as state for this workflow. So how do we do that? In our executors, we get this context, and the context has state. So what you're going to do is use set state on that context and get state on that context, right? So let me open this up here, workflow, conditional, state. Okay. So here we've got various executors. And so this one has, actually the way I did it this way is that I made a pass-through executor to store the post text, right? Because since I'm not using custom executors, I'm using agents. So this way I'm basically directing all the agents that need to store it. I just direct them to this executor afterwards so that they can store the post text. So this is a executor whose only job is to store text. And then when we need to access it, we can do get state from that context. So executors always get passed a context. So you always, from an executor, you should always have the ability to retrieve state or set state. So let me go ahead and run this. This is going to look like, it's going to look really similar to ones we already showed. This is just an implementation detail where we decide like, okay, actually we're going to be, storing this instead of just having it be passed along. And let me run it in DevUI as well, so we can see what it looks like in DevUI. Okay, state py DevUI. Okay. So that's running. Does the state management reduce token usage? Yeah, state management could also reduce token usage. That's a great point. Yeah, because the agents aren't having to carry along. So certainly state management, it's kind of a mini version of memory, right? So yes, state management could reduce token usage. All right, so this is where you start to see like workflows that are kind of crazy looking because of the way the way things are going. Because in this case, both the writer and the editor can store the post text. This one's hard to look at. This is why it's useful to be able to like drag things around to see if you can come up with a way of looking at it, which makes more sense. And so there we go. So it's done. So the output looks the same. The difference is, that we're storing that post text in the state, and we're being really explicit about accessing it. And yeah, as someone pointed out, we are able to reduce some token usage as well. Now, there is a danger to having state. So do proceed wisely once you start storing state if you are reusing a workflow across multiple runs, right? So you make a workflow instance when you do workflow builder.build, that makes a single workflow instance. That workflow instance has its own state, and it has just one state for that workflow, right? So if you are doing workflow.run like in parallel with that same workflow object, you are in fact using the same state. So if your key is just something that's the same across all those runs like post text, and you do multiple workflow runs in parallel with the same instance, then you could have a race condition where you're trying to access the same state. So what you should do instead is either you create, you run that .build multiple times so that each time you're getting a fresh workflow instance, or when you're storing something in state, you got to use an ID, an identifier to say, hey, this is the identifier for this run. This is the identifier for the other run, right? So either way, like either use a whole brand new workflow instance, or you're namespacing your keys in the state so that they are not going to overlap with each other. So keep that in mind. The other issue is when your workflow has agents have their own kind of state, which is their conversation history, right? We talked about this last week where they have their sessions, which has history in it. So if you are using a workflow with the same agents and you do multiple runs of that workflow, then those agents actually still have their old session history. So they could get tainted by their previous session history because they remember what they did before. So you want to be really careful about agent instances and being, really, mindful of when you're using the same agent instance. So what we can do to isolate our state is that we can just use a function that creates everything. So this create workflow function, it'll create agents and it will build the workflow, right? So every time we want a workflow for a new prompt, we could call that function, and then we have a workflow instance, and we'll just call run with that workflow once, right? And so this way, all of the state is isolated because every time we want a new workflow, we're gonna call that function, get a new workflow, and run it. So you can run that example if you want. The output is the same. The difference is that now we have better state isolation. Okay, we have 2 minutes left. So I wanted to show a brief example of, what might a user-facing UI look like for these agentic workflows, right? So I have it open here. I've got it running locally. This is a pretend shop. I'm logged in as the manager, and it says, uh-oh, I've got 12 products running low on stock, and it has this AI agent to help me do stock. So I'm going to launch the analysis. And here we can see in the front end, it's telling me the progress, right? It says, oh, okay, we ran this agent, we ran this agent. And that's what it's saying, like when you're building user interfaces for these workflows, you probably do want to indicate, show the events that are happening along the way so that people get feedback about how things are going. And then you have the output and you're going to, render that as well. So this is just to give you an idea for when you're building these into your applications, what might the user interface look like? I have for the next two sessions, I have two other applications that I'll show you. So we're going to see multiple examples of how you would integrate workflows into user interfaces. And that's the code here is similar to what we saw before, right? We've got, this is just a stock, and then we've got edges between these executors, right? So the code is what we've been seeing. It's just the user interface is a bit fancier. All right. That brings us to our final minute. Now, I know there's lots of questions we didn't answer, but the good news is that we have office hours right after the session in Discord. So you can come on over to Discord with your questions for those office hours. Please do bring them. We've got lots of time to talk. We are going to be on a different stage in the office hours this time. So there's now two stages in the Foundry Discord. So make sure you join the right stage. Just look for me and everyone else talking about agents, and you can look at the event listing too. So just FYI, we do have two stages. Join the correct stage, and if you're in the wrong stage, just come over to our stage. So come for office hours. And if you missed any of the previous recordings, you can get it from this link here. We've got recordings, slides, annotated write-ups, office hour write-ups, everything for you to learn from. And we do have two more sessions left this week where we're going to build more advanced workflows. So tomorrow we'll talk about concurrency, fan out, fan in, aggregation, more interesting patterns. And then on Thursday, we'll talk about adding a human in the loop to the workflows. All right, everyone. So that brings us to the end of the YouTube stream, and I hope to see a bunch of you in the Discord. Thank you, everyone. Bye.
Thank you, Pamela. Thank you all for joining. To keep your experience good, we always look to improve it. So please take a moment to share your feedback in our survey. You can find the link in the chat or on the screen, and we'll see you in the next one.